In this video, we are going to learn how to solve trigonometric equations using a graphing utility. For these three examples, we're going to use a graphing utility to solve each equation and express the solution in radians and degrees rounded to 2 decimal places. So in order to solve these equations, right now I have sine of x and x, which we learned in the last video. And the one before is we can't factor this because they're not similar terms. So we're going to come across some issues in terms of trying to solve this by hand. So if I go to my graph and calculate and hit y equals, I could input the left side of my equation as y1 and the right side of my equation as y2 and see where they intersect to be my solutions to the system. So we have 5 sine of x plus x, and that's going to be equal to 3, so y2 will equal just 3. And now I will graph. You'll see this first function, that's this 5 sine of x plus x. It's basically a sine of x function, but on an angle, a line of like y equals x. And we have our y equals 3 line going straight across. You'll see here it intersects a few times. So these are 3 solutions to this equation. Now my calculator is in radian mode, and that's very important, especially for graphing, because you usually get nice graphs that way. But it's also for my solutions later. It helps me keep track of what type of answer I'm getting. But I have 3 solutions, so I'm just going to write x equals 3 times for my 3 solutions. And I'm going to hit second trace, which brings you to a calculate menu. And I'm going to use this intersect feature to find the point of intersection. Now the way the intersect feature works is you'll follow one curve and you'll move it as close to one of the intersection points as you'd like. Our first one's about right here. And we'll hit enter. Now it'll ask me for the second curve. That means we're on the y equals 3 line now. You can even see it notified in the top left. And again, I want to pick a point near that point of intersection as well in the second curve. Then it'll ask me to guess. So I picked 2 points, one on each curve, and now it's going to guess until it gets the one that's equal on both by plugging in values around the 2 we picked. When we're done, it'll say y is equal to 3, which makes sense. That's that horizontal line. But it's the x value that's our solution. That's what we're looking for, which in this case is 0.159. But it wants 2 decimal places, so it'll be x is equal to 0.52. And if I want to find another intersection, I'll do second trace, go to intersect, and again I'll move from the first intersection to the next intersection on my first curve. And my second curve, again, it'll always attempt to pick one nearby, so sometimes you don't even need to move it. And then guess what that one is. It highlights it as 3.177, so that's 3.18. And again, second trace, look for the next intersection. Follow along my curve here. You'll see at the top is indicating this is 5 sine x plus x. And the second curve is right here. And I'll get the intersection point 5.71. So those are my 3 solutions. Now, if I want to put this into degrees, I can just do second mode, go back to my open menu here, and use that conversion rate to put this into degrees. So 0.52 times 180 over pi, which would be 29.79 degrees. Then 3.18 times 180 over pi, which is 182.2 degrees, and 5.71 times 180 over pi, that's 327.16 degrees. Now, here it's asking you to express it in radians and degrees. In most cases, this will just be expressed in radians in most applications, but it's good to know how you can move between the two in case x is representing an angle. And those will be all my solutions. So let's try the next one out. So we'll go back to, we'll do second mode, or sorry, we'll do clear, and we'll go to y equals, we'll clear out both of those functions. Now we'll put in x squared, that's my y1, and x plus 3 cosine of 2x and graph. So there's my x squared function, and here's my other one coming in. And it looks like it crosses twice, and it just misses over here. So we have 2 intersection points. Now, it seems very small and compact, so if you ever need to, if you go to window, you can make a smaller window. So I can go from -5 to 5 on my x's and -5 to 5 on my y's. And it'll give me this, it'll regraph it, but a little bit closer up so you can get a better picture of it. And you'll see here 1, 2 intersection points, and it just misses for the other one. So now if I go to second trace, intersect, I move to the first intersecting point, and I hit enter. I can just hit enter again because it's picking another point nearby, and then guess. And the intersection point is at -0.616 or 62. Now I can get my other one. Second trace, go to my intersect function feature, move over to the other intersection point, and I usually just hit it again because even though now I'm on the other curve, it usually picks the point nearby when you're doing the second one. Guess, and we get 0.81 in radians. So second mode, if I were to convert these, I would have -0.62 times 180 over pi to convert it. Oop, I made a mistake. I'm looking at see where it could possibly have been. I'm not super sure, so I'm going to put -0.62 in parentheses times, again, 180 divided by pi, and close my parentheses. And I get -35.52 degrees. And convert the other one, 0.81 times parentheses 180 divided by pi. And I get 46.41 degrees. Now let's do this last one, because the last one has an important extra definition that I want to tell you why that's here for this solution. So let's go back to y equals, clear those out. y1 will be 6 sine of 2x minus e to the x, which is right above the ln key. So second ln, x, and close those parentheses. That's equal to 2. So now when I go to graph, you'll see this graph goes up and down quite a bit and actually repeats this on and on to the left. So you see we'll actually have a lot of solutions going on to the left because this actually creates a wave that goes up and down forever. So you'll have an infinite number of solutions. But we're going to restrict the domain to just be positive x's. So everything right of the x-axis, which happens to be 2 of the intersection points. So we're just going to find those 2, and that'll be our solution. So near the first intersection point, we have x is equal to 0.295, so that's 0.3 when rounding to 2 decimal places. And second trace, intersect on the other one, move up the curve, back down. And guess, and we have 1.08. So x equal to 1.08. So these are your 2 solutions. So instead of writing down all these solutions and trying to come up with a general formula, which would be very difficult, we're just going to go with the 2 that we can see within that domain. So now when I want to convert these, 0.3 times parentheses 180 divided by pi, I get 17.19 degrees. And then 1.08 times 180 over pi, I get 61.88 degrees. And that is how you solve trigonometric equations using a graphing utility.